blocks of Terraform. So yesterday we saw the resource block and the provider block. Now there are other blocks as well. If you remember when we discussed in the theory, we have other blocks like data block. Uh, we have a variable block, then output block. We have locals block. Then we have provisioner block, module block, and uh, backend block. Right? So these are the other blocks that are part of Terraform template file. So these two we have discussed yesterday. That is the resource block and the provider block. Now remaining these blocks we will discuss today. That is data block, locals block, variable block, and output block. So we will discuss these blocks today. And these three remaining blocks we will discuss in the next session. So let us try to create the resources with the help of these blocks, right? Or let's see how these blocks can be used in the Terraform template file. So for that, I will go to my VS Code, or else I'll directly go to the directory where my code is present over here. This is where I created the code. Now, if you directly want to jump to your VS Code from here, just in the address bar, type cmd. It will open command prompt in this location. So this is a shortcut. Directly, it will open VS Code from here, and just type code dot. So it will open the directory and files in VS Code. You can close the command prompt if required. So this VS Code has opened. Right, it will directly take you to the files that are Terraform files. So let us discuss how to create other resources. So these Terraform commands we had discussed yesterday. Provider block also we had discussed. Now let's try to create three EC2 instances. Okay, so let me try to write the code here. So AMI, I will enter the AMI name. So I will create Amazon Linux 2. Instance type, let me keep it as t2.micro. And the tags I will give it as my server. You can give any name. Right? So this Terraform block and provider block is already added, and then I've written this resource which is used to create EC2 instance. I've given the MAID instance type. Okay, now this what it will do is it will create one EC2 instance. Now let's say if I want to create three EC2 instance, just add the parameters count equal to 3. That's it. Now let me try to run the commands terraform apply --, auto approve. It has started. So using this code, you can create multiple EC2 instances in one go. So yesterday we had seen how to create one EC2 instance. Now this code will help you to create multiple EC2 instances. So we will wait until this code gets executed. Now you can see three resources got added in few seconds. Three resources got added. Now I will go back to my AWS account just to verify it. You can see three resources got added over there. Now I my requirement has changed. I don't want the name to be same. Here all the names are same. My server, my server, my server. I want the name as server 123 like this. So how can I achieve it in Terraform? Now here I just want to modify it. I don't want to recreate these instances. Okay, these instances are already created. I just want to rename the tag. Now for that, how can I achieve or how can I give the name for all these three instances? So all you have to do is you can uh, make use of a parameter called as count.index. So for that we have count we have discussed. So count is used to create multiple EC2 instances. And another parameter that we have is count.index. Now count.index will help you to uh, it will help you to rename or we can say give a give ascending names to the servers, right? If you want to give the name as 123, you can give it with the help of count.index. Now, one thing we should remember is that the count.index, the first value starts with 0, then 1, then 2, and 3, and so on. So the first number in count.index, it starts with 0. Now let's test it. So I'll go back here, and what I will do is instead of this my server, I will name it as server, and just call the variable, open the braces, count.index. So this is how it should be written. Let me just verify it. Okay. So what I've done is I've just added count.index, and let's try to modify these changes. So I'll run Terraform apply, happen auto approve. So we'll wait for few seconds. Okay, you can see here nothing is added. Just that it is trying Terraform is trying to change three things. So it will just change the name. Okay. Now you can see three changes have been done. So let me go back here and hit refresh. And you can see if I arrange them in ascending order, the names are server 0, 1, 2. But I don't want this. I don't want it to start from 0. I want it to start from 1. So that for that you have to just make a slight modification. Just add a plus 1. That's it. And now if you try to apply it again, let's see what happens. So I told you the index value starts with 0 first. Okay, so that is the reason why it started with server 0. But you can just give plus 1 over here and it will start with server 1, 2, 3, okay, and so on. So we'll give it couple of seconds, and this should change the names to server 1, 2, 3. So these three changes will be done. So you can see here in the output only it is showing server 2 will be changed to server 3, server 2 will be changed to server 3, that is here, and 1 to 2 and 0 to 1. You can see that output you should be able to see here, and I think it is done. Now just go back to your AWS and hit refresh. You should be able to see server 1, 2, 3. Still refreshing. You can see server 1, 2, 3. So this is how you can create multiple servers with the help of count. Okay, the attribute count, it is called as an attribute count, and count.index will help you to give the count to the different servers. Okay. So this is how you can create multiple instances. We are still in the resource block. Okay, we are still in the resource discussing the resource block only. Now this is how you can make use of count and count.index. Now, one more thing is that you can divide the files into, or let me keep it here only in the main.tf file. Now, let's see how to add the key to these instances. Now, let's go back and check with the key. So, I'll just check any of these instances. And let us check the PEM key. So, which PEM key has it considered? We will find it somewhere here. Now, you can see key pair assigned at launch is nothing. So, it has not considered any key pair. So it has created these EC2 instances, but no key has been attached. You see, so like there is no key that had been attached. Now, how to attach the key to these EC2 instances? So you have created three EC2 instances, and I want to attach a key to these EC2 instances. So how can I attach a key to the EC2 instance? So let's see that attaching the key to an EC2 instance. Now in Terraform, there is no automation wherein you can create a key because what happens is, let's say you have written a code. How will you download it? So downloading is not possible, right? If you even if you write a code for the key, you cannot download it. There is no download option in Terraform. So this is one thing that we should remember is that when we are using the like if you want to attach a PEM key to our EC2 instance, that needs to be attached. Either you can create a key manually from the AWS console, or you can make use of the existing keys, right? Either of the things you can do. So let me go back to my AWS console, and here you will find something called as key pairs, right? So just click on this option and get the key name. So currently in my account, I have one key that is Linux underscore key. If you want to create a new key, you can create a new key and you can keep it in your downloads folder. That is one way. I already have one key. I will just make use of this key. So just copy the key name here, and if you want to add the key to these EC2 instances, just add key underscore name is equal to the key name. That will be in the quotes like this. Don't add the extension .pem. Okay, so don't do that mistake of adding the pem .pem extension. You have to just copy the key name, and that will help you to add the key to your EC2 instances. So let's try to apply it again, and let's see whether the key will get applied to all the three instances or not. Now, what Terraform is doing is it is destroying all these three EC2 instances, and it is recreating these three EC2 instances. The reason behind that is you cannot attach a key after the EC2 instance is created. Okay, so there is no option of attaching a key after the EC2 instance is created. That is the reason why Terraform will destroy and recreate these EC2 instances. Now you can see three resources got added. So let's go back and verify whether the key has been added to these EC2 instances or not. Now I can verify it, I think from here only. It is still refreshing. We'll give it a moment. So these three instances are added up here. And if you just filter out the running instances, quite slow today, then you should be able to see the key name over here. So this key got added to these EC2 instances. Right now, you can access these EC2 instances by using this key, linux underscore key. Now, in case if you want to create a new key, you can create a new key, and that key name you have to just add it over there. Okay, so that is how you can uh, provide the key name. So this is how you can create EC2 instances. You can create multiple EC2 instances. You can make use of the count.index, and you can also attach the key to these EC2 instances. Now the question is that this EC2 instance will have a security group, right? If I go to the security group and check the security group, it will have certain security group. So this it has taken the default security group. So all these three instances that are created, they have taken the default security group. But I don't want to make use of the default security group. I want to, I want to use the existing security group that is present in my account. Okay. So there is another way where you can define the security group also that we will see at later point of time. I have already explained that in project. But let's say I already have a security group in my AWS account and I want to make use of that security group. So for that, we will be discussing the data block. So data block is used to pull the existing resources in your Terraform code. So if you remember theoretically, we have discussed the data block that it is used to pull the existing resources in your Terraform code. Now what we will do is rather than recreating these EC2 instances, I will just modify the security group. I think that is possible. Let's check it. Or else it will recreate the EC2 instances. Doesn't matter. We just want to add a security group to these EC2 instances. So let's say we had created a Linux security group, right? Wherein we had added port number 2280 right? I want to make use of this security group. So for that, you can make use of the data block in your Terraform code. So let's use the data block in the Terraform code. So what I will do is I'll just add data block followed by the resource name. So it will be AWS underscore security group, and then followed by the custom name, let's say my, or you can give any name, my security group, and then you have to just add the in the data you have to add the value. I guess one second, let me check it. Okay, let me add the ID here. So either you can add the name or you can add the ID here. So ID equal to, you have to just pull out the ID of your security group. So go back to your AWS account and copy the ID which you want to use. So this is the Linux security group ID. Copy it and go back to your code and paste that ID here. And here in case if you want to call this here in your resource block, you have to just add a uh, you have to add an attribute which is called as VPC underscore security group underscore ID is equal to, and then you have to just copy this part, paste it here, and just give data dot aws security group dot mysg dot id. So it will take the ID of this security group. Let me just verify it once. It is IDs. Why ID is because you can add multiple security group to your EC2 instance and just add it in a square bracket because it is a map of multiple values. Okay, it is a sorry, it is a list. Okay, so it can be multiple uh, security groups. So you have to just add it like this. Okay, so you have to add it in a square brackets. Now let's try to apply it. Terraform apply, and let's see whether the data block will inherit the security group to that EC2 instances or not. Now, I told you it will not recreate the EC2 instance, it will just modify the security group. So that is why it is just try to change it. Right? So now the three resources have been changed. Now if we go back and if we go back to the instances dashboard and check the security group attached to those EC2 instances, ideally it should consider the Linux security group. So we will just refresh them once. It's still processing. Why it has not given it? Here it is giving an output that this security group has failed. Let me refresh the browser. One sec. Now you can see the security group has changed. So in case if the changes are not reflected, just refresh your browser. Okay. So this is the security group which has been considered for all these three instances. You can verify it like this. So this is how you can make use of the data block and use the existing resources that are part of your AWS account. So this is how I made use of the data block and I called the existing security group in my Terraform code. And here you have to just add data block dot the resource name followed by the custom name dot id, because since we are putting the id, so to just add dot id like this. Now moving ahead, let us discuss the output block. We can discuss, or we can also discuss locals block. Let us discuss locals block first. Okay, let's see what I've written for. Okay, so using locals, I told you you can declare the variables locally. Okay, so using the locals block, you can declare the variables locally. Before that, what I will do is I will just create a simple EC2 instance and let me just delete whatever I have created, or I can simply modify it here if required. Or let me just destroy it, no worries. Terraform destroy hyphen auto approve, and I'll just create a new EC2 instance using locals block. So I just wanted to show you how to make use of locals block. So I'll just remove this data part. I will just create one EC2 instance. Key also, no, not required. So I'll just try to create a simple EC2 instance. I will add locals block, locals, and then you have to, let's say, I will give the name, let's say, uh, I will give the name as, you can give a tag equal to. So let's say I have given the name equal to web server, and owner is, let's say, my name, I am the owner, and the environment is, let's say, production environment. So you can give multiple tags like this. So I've declared the variables locally, and in order to make use of this local, these tags, all you have to do is inside the tags, go to remove this part and just add local dot tag. That's it. So what this will do is it will call the local tag. Whatever tag that you have given, it will call it like that. And you can just remove this part because it will take all the values. Name is something, sorry, local dot tag. So it will take everything, name, web server, all the. So this is a set of values, right? Tag will consist of multiple values, key value pair. Sorry, I missed one thing. Owner is equal to, and environment is equal to production. This is how I need to mention the key and value pair, right? So tag has a multiple list of key and value. So this tag itself is a set. So I just need to call local dot tag like this. Okay, this is how I need to call it. Now let's try to uh, create this EC2 instance with multiple, multiple key value pair in the tags. So let's try to run Terraform, apply -f auto approve. One thing you should remember, I told you previously in the theory that locals block are defined as a plural, wherein you will be writing locals. But when you are calling it, it will be only local. Right? It will be like local dot followed by the local name. So this is the local name, right? The name is tag. That is the local name that I've given. So you have to call it like local dot tag. So declaring the locals block will be like locals, plural. But when you are calling it, it will be singular. So we'll wait for a few seconds and let's see whether the tags will be applied to this EC2 instance or not. So it will create an EC2 instance with the name web server and it will have additional tags, owner, Nasir, and environment production like that. Okay, so that is the additional tags that it will have. So this is completed. One resource has been added. So let's go back and verify our EC2 instance. Let me just hit refresh here. You can see web server got created. And if I select this web server, and in the bottom I will find an option of tags. You can see there is a tags. So go to the tags, and here you can see the tags that are defined. So that is where I define the locals tag, right? So this values has been taken in that EC2 instance. So this is how you can declare the variables locally. Now, whatever variables that you declare locally, they cannot be overwritten by variables.tf or terraform.tf vars file. So this will come to another concept wherein we need to discuss something known as uh, Terraform variables.tf and Terraform.tf vars. So what are these files? We will discuss in some time. So we have seen how to declare the variables locally. So whatever variables that you declare that you declare locally, they cannot be overwritten by any variables, right? Any Terraform variables that you have, you take that cannot be overwritten. Locals variable will have the highest priority if you have declared it locally in the code. Now let's say I will remove this locals variables, okay, and I will just bring it back to tags equal to name equal to web server like this. Okay, I will declare a variable, or let's say I will give a single tag to this EC2 instance. Now, what I want to do is every time I don't want to enter this AMI ID and T2 micro, I want to variabilize this so that I can change it. Because see, this is just a small code that I've written. I may write multiple, like, I may have to write a bigger code wherein, this EC2 instance and AMI ID may come frequently again and again. So rather than hard coding it here, I just want to variabilize this. So just cut it here from here. Let me cut it and put it somewhere here. So AMI ID is something that I want to variabilize. T2 micro is something that I want to variabilize. Let me put it like this here. These are the values that I want to variabilize. I want to give them some variable name. So let's say I will give the same name, and for AMI ID I will give the variable as AMI. Instance type also I will give the variable as instance type only. So the next part that we are going to discuss is variable block. So variable block is used to declare the variables. So we have discussed this theoretically, how to declare the variable block. Now we will do it practically. So variable block will be written with the name as variable followed by the variable name. So let me give the name as AMI only. And then here you have to add the default value. Whatever default variables that you want to declare, you can declare it like this. So AMI will be this. I'll put it here. And if you want, optionally, you can just add the type equal to string. So this is optional because string is something that is default. It will consider the string. But if there is a map of values or list of values or let's say set of values, then you have to define the type. So let me define the type equal to string. Anyways, even if you don't define this, this is totally optional. Okay, you can just skip this part if required. As of now, I'll just skip it. Or let me write it so that we can see the types of variables as well, data types of variables. And here I will write another variable called as AMI, and the default value of that variable will be default is equal to the AMI ID. Sorry, let me correct it. This will be instance type, instance underscore type. So I have declared two variables. One is AMI. This is one variable. Another variable is instance type. So you can give any name. Okay, I've just chosen a similar name so that there won't be any confusion. I've just chosen a similar name. So here I have to call these variables. So how to call the variable? You have to just type var.ami. What is the variable name? Variable name is ami, and likewise in the instance type it will be var.variable name. So my variable name is instance type only. So var.instance type. So this is how you can call the variables in your Terraform code. So you have to write the variables, default variables, whatever default variables you are declaring, and you have to just call it using var.ami and var.instance type. Right? This is how you can call the variables, or you can declare the variables. And even if you want, you can variabilize this part as well. Web server also I want to variabilize. So I'll just call the variable as variable is equal to, let's say, tag, and default value is equal to web server, right? And just over here I've defined the type. Here I've not defined the type equal to string. So I can just show you that it is anyways optional. And here if you want to use this variable, so var.tag. So this is the variable with the name tag. So what this will do is it will create an AMI. It will fetch for the variable. What is the variable? This is the variable. So it will consider this AMI ID. Then it will create the instance type. It will pick up the instance type variable. What is the instance type variable? Is T2 micro. Then it will go to tags. Name is equal to var.tag. Now what is the tag value? It is web server, right? That is the value of web server. So here it is showing me a problem. Let me check. Invalid expression expected the start of an expression. Tell me something here. Okay, good. Anyways, let's try to run the command. So I'll just clear the screen and apply Terraform apply hyphen auto approve. So this is how you can declare the default variables, right? So that is the reason why it is in the attribute it is called as default. Right? Here that is the reason why I've written it as default. So these are default variables, and this is how you can declare the default variable using variable block. So variable block is used to define the default variables. So we'll give it a few seconds. And this should create a web server with a T2 micro and this MEID. Right? So that is what our requirement is. So it has started creating the EC2 instance. So now it has added that EC2 instance. So if I go back, the tags will not be there, I believe, because I've removed the tags. If I hit refresh, because I had declared the tags with the help of locals block. So these tags should not be there anymore. So you can see the tags got deleted. Web server got created with T2 micro and the MEID, whatever MEID we have provided. So this is how you can declare the default variables. So nothing, I did not change much. I just variabilized the components. So I variabilized the MEID, I variabilized the instance type, and I variabilized the tags. Now in Terraform, there is a standard practice that rather than writing this in a single file, you can divide this file. Okay, you can just bifurcate the file into uh, different smaller files for for ease of understanding, right? So you can put these variables inside another file which is called as variables.tf. So here what I will do is I'll just pick up these variables. I'll cut it from here. I will create a new file here with the name variables.tf. Because it has multiple variables, that is the reason plural variables.tf. So this is where I have defined the default variables. Define the default variables, right? And also what you can do is this provider block also you can put it another file called as providers.tf. So this part, Terraform block and providers block, you can just simply remove it from your main file, create another file with the name providers.tf and just paste it over here. So here in the file, you have to keep providers.tf, and in the variables.tf, you have to keep the default variables. Remember this part. I am, I am putting a strain here that it is default variables. Right? These are default variables. Now, okay. And this is where you will be having the main.tf file. This is your simply create EC2 instance code. So that is totally up to you. If you want, you can keep everything in a single file. But just as a standard practice, these files are divided into multiple other files. Providers.tf will have the Terraform block and the provider block. Variables will have the default variables, right? So it will have the default variable like this. and these variables I'm calling it in the main.tf file. I have not done anything. I've just created separate files. That's it. Okay. I've just shown you how it is followed as a standard practice in Terraform. In Terraform, you will write the main.tf file wherein you will just write the code, what resources you want to create. Mostly resource block, data block will be part of main.tf file. Variables will have the variables block. Providers will have the provider block. Okay. Now, one thing what I want is here. Uh, what I wanted to show you here is we have seen the variable block wherein we have defined the default variables. Right? This is a default variables. Now let's say, or let me take it here. So we created a file with a name variables.tf which has the default variables. Now there is another file. If you remember in the theory I told you there is another file which is called as terraform.tf and I've just given it a higher position. Why? Because it is uh, whenever we're trying to apply, terraform.tf vars file will be considered first. After that, variables.tf var will be considered. So these variables.tf will have the default variables. Now please focus here because this is very important from the interview perspective. And terraform.tf vars will have the variables which can be overwritten or overwriting variables. Now let's say you have already declared some variables in your default file, that is the variables.tf file, which will have the default variables. Now I will create another file with the name terraform.tf vars file, and this is how it has to be written. Okay, do not change the name. This is a standard naming convention for terraform.tf vars. These are the, and this is where you will be defining the overwriting variables. These are the variables which will be overwritten. Whatever variables that you have in the default file, they will be overwritten. Now let me come back to the default variables. I'll copy it and I'll paste it here. Now you will be thinking that we have to define it like this only. No, you will be overriding variables will only be will only have the key and value. So this is the key, this is the value. That's it. Remove extra parts like this. So discard this part and discard this part till here. So it will only have key and value combination like this. So the key is tag and value is web server like this. So this is how you will be defining the terraform.tf vars. Okay, I'll just remove the extra spaces. Okay, very simple, and let it be like this. Okay, or let me keep it as key equal to value. So just remove these quotes. This is the key. So key should not be in quotes. Only the value has to be in the quotes. So the key is AMI, value is this, key is instance type, value is this, key is tag, value is this. Now, both the values in Terra for variables.tf file, default variables and the overriding variables are same. Let me make a slight change. Here, instead of key to micro, what I will do is I will keep it as key to medium. And instead of web server, let me call it as, let's say, my EC2 instance. I'll give it a bold name, my EC2 instance. Uh, in uppercase. Okay, so I will give it a name. I have just changed the instance type and I have changed the tag. So what do you think? Which file will get applied? This terraform.tf files will get applied, or variables.tf where variables will be considered, or let's say which variables will be considered. In the both the files, I have defined some variables. Here also I have defined instance type. Here also I have defined instance type, right? But main.tf, which file will it consider, or will it consider? So now main.tf file will consider the variables from the terraform.tf file, because this will be, we can call it as it is superimposed on variables.tf file. It will override the default variables. So the purpose of terraform.tf var files is to override the default variables, right? So how this will be useful in real time, that we'll be discussing in project and all. So main.tf file will consider the terraform.tf variables only. So let us test it whether this is true or not. So we'll go back to the code. And let's try to apply Terraform apply auto approve. And let's see what happens. Whether here I have defined T2 micro, and here I have defined T2 medium. So here I have defined micro, here I have defined T2 medium, and I've changed the instance name as well. Right here I've given it as my EC2 instance, right, like this, and it is T2 dot medium, right. So let's verify whether this will get applied or this will get applied. And here the name is, let's say, web server, right? That was the name. So as I told you already, terraform.tf file is, it will be considered above default.variables. And on top of it, we have locals. Okay, so locals will be always at the top. So if you define the variables locally, that will be considered first. So from the priority perspective, locals will always be at the top. So these are the local variable, wherein we are defining it in the local main.tf file. Okay. So this is not a different file as such. So let me call it as just locals. But these locals will be defining in the main.tf file. So when it considering the files, terraform.tf files file will be considered as priority. But if you have a locals block here in the mains.tf file, then this will be considered. So locals will have the first priority, terraform.tf files will have the second priority, variables.tf file will have the third priority. So now in our case, it is terraform.tf file. So this file will be considered. So let's go back to the code and let's see whether the code has run or not. It is still running. So now you can see here, web server will be renamed to my EC2 instance. And here T2 micro will be changed to T2 medium. Right? You can see that in output itself. So it is just modifying the instance type. Okay, so instance type you can modify on the go. That is the reason why it is not destroying and recreating the EC2 instance. It is just modifying the instance type, and parallelly it is also renaming the EC2 instance name. So now you can see the changes have been reflected. So here previously it was T2 micro. So if I hit refresh and the web server, that was the name. It is still loading. And now you can see it is T2 medium, and the name has also been changed. That is my EC2 instance. So whatever values that we defined in the terraform.tf var, that were considered. Right? So terraform.tf var file is used to override the default variables. Okay, so this is will always have a it will always be considered as a priority on top of the default variable. Now let's not run T2 medium. Okay, so I'll just remove this, or else I can simply delete the terraform.tf file. That's it. Now if you try to recreate it, it will create it with T2 micro. Whatever default variables you have defined, that will be considered. Now let us discuss uh, the another block, that is the output block. So output block is used to pull out the output variables. If you want to get some output from your EC2 instance, it is used to pull out that output. Okay, so you can just declare the variables. You can declare the output variables with the help of output block. Now, if you want, you can just give the output. I'll write the output here. Output block output followed by the name that you want to give. Let's say my EC2 public IP. I want to pick up the public IP and I want to display it in the screen. So it will be written as output value is equal to. So this will be the value AWS instance dot my EC2. Just copy it as it is. Remove the two quotes and just put a dot. Dot what do I need? I want the public IP. So here in the output only you can find something called as this is the public IP. So it will be public underscore IP like this. So just copy it and paste it here. So it will be public dot IP. Just let me just verify it. Okay. So this is how you will be writing the output variable. Now using output variable, it will after the EC2 instance is created, it will display the value of your EC2 public IP. Right? That is the purpose of output block. So let me clear the screen and let me type Terraform apply hyphen auto approve. So rather than going and checking the public IP from the EC2 console, it will just display the public IP on the screen. So I'll give it a couple of minutes. And so what output will do is it will just display some output variables. Let's say you want to pick up the public IP, private IP, DNS name, private DNS name, private public domain DNS name. All these value can be fetched using the output block. Not only that, if you want to pick up the EC2 instance name, EC2 security group ID, EC2 instance ID, all this data can be fetched with the help of output block. Mostly we will be using it to pick up the public IP, private IP, because or else I have to go to the EC2 console and from here only I will be able to get the public IP and private IP. So I don't want that. I want that it should be displayed within my code only. Right. So now you can see it is applying. It is just changing the T2 medium to T2 micro, and we'll give it few more minutes. And this EC2 instance, my EC2 instance has been changed to web server. So because I have removed that terraform.tf file, right? That is why. And this T2 medium got changed to T2 micro. You can also fetch the public IP from here as well, right? So now it is not known yet. So this will only be known after it is completed. After the EC2 instance is created, only then you will get the public IP, not before that. And you can also get the public IP from the state file as well. But I want it should be displayed on the screen like this. Now you can see here at the bottom, my EC2 public IP. This is the variable that I had given. It has given the value 44,203,251,93, and you can go and verify it from your console. Just give a refresh. So this T2 medium will change to T2 micro, and this instance name will also change. And the public IP, whatever public IP of the new instance got created, that will be displayed here. So you can see public IP has been displayed here. Similarly, you can also pick up the output of private IP. So instead of public IP, just write it as private IP like this. So just remove this public IP and just give the name as private IP like this. So let me just keep it as public one. Now this output block can also be written in a file called as outputs.tf. So whatever blocks that we have written, you can just uh, create a different file and you can just put the blocks there. So main.tf will pick up that blocks from there. Okay, so it will just consider that. Main.tf will have the resource block and mostly data block. Output will have the output block. Provider will have the provider block with the Terraform with the provider version. Variables.tf will have the default variables. And another file which we had created was terraform.tf var files, which will have the overwriting variables, right? So these are the important files that are part of the Terraform code. So we have discussed the resource block in the main.tf file. Then the provider block we have discussed, output blocks we have discussed, locals block also we have discussed in the main file, variables.tf variables block we have discussed, variable block, and we also discussed the variables.tf file and the terraform.tf var files. So this question will be asked in interview. They will ask you what is the difference between variables.tf file and terraform.tf var files. So you should be able to explain them the difference between terraform.tf var and variables.tf var. Okay, so this will they will definitely ask you in the interview what is the difference between terraform.tf vars and variables.tf vars. And also when they ask you the directory structure, tell them that we have a directory dot directory wherein the provider plugin is stored. We have the log.html which will be logging the provider version. Then we have the state file, terraform.tf state file. Then we have the terraform.tf state.backup. Then we have the main.tf file wherein we'll be storing the main code. Output.tf wherein we'll be storing the output variables. Providers.tf wherein we'll be storing the provider data, the provider version, region, etc. And the provider name, that is AWS. And variables.tf file is used wherein we will be storing the input variables, right? And terraform.tf var is wherein we'll be storing the overwriting variables. So if you want to override the variables, that can be easily overwritten with the help of Terraform.tf var files. So we have discussed all the important blocks in this code. Now let us discuss one more attribute which is called as for each, right? So this part is still remaining. Okay, let us discuss that. Now let me go back to the main.tf file, and here let's say you want to create an EC2 instance. Let's say you want to create three EC2 instances. I'll just show you here in the diagram. So let us discuss for each attribute for each. So this is another important attribute, and this will be asked in interview. What is for each attribute? So for each attribute is used to give key and value to multiple resources. For example, let's say I want to create three EC2 instances. One I will create it as small t2 dot small. Another I want to create it as t2 dot micro, and then another I want to create it as t2.medium. So I want to create three EC2 instances with three different instance types, and I want to give them three different names. So let's say I want to give it as this as a web server. Another EC2 instance I want to give it as app server, and another EC2 instance I want to give the name as database server. And along with this, their instance type is also changed. So this will be like t2.medium. This will be like t2.micro, and this is t2.small. So these are three EC2 instances with three different instance types. So we can create this kind of requirement can be achieved with the for each attribute, wherein you can define key and value pair. For example, you can consider this as a key and this as a value. Okay, so let me write it here. Web server should be created. This is the key, and the value of web server is t2.small. So you can create a key value pair like this, and app server, this is the key, and the value is t2.micro. And another we have db server, so this is the key, and the value is t2.medium. So you can create a key and value pair. So here for each we'll have key and value like this, key and value like this. So it will pick up the key and value. So it will be written like each dot key, and another will be each dot value. So this is the for each. You will be writing the for each like this at the bottom. And when you will be calling it, you can use it. So let's say if you want to call the keys, you will be calling each dot key, and when you will be calling the value, you will be calling it as each dot value, like this. Okay, so this is how you can make use of the for each attribute. So let's see this practically how to use it. And this for each will be written within the resource block. Okay, so I'll just show it here. So it will be written in like this. It will be a set of map. Okay, so this will be a set of maps. So I'll just show you. Let me go back to the code. I have variabilized. So let me just delete everything. Let me destroy this first so that we can create a fresh EC2 instance. So this has been destroyed. I'll just remove unnecessary files here, delete them. Provider I need to keep. Terraform.tf I'll delete. Variables also I'll delete here. So let us see how to make use of the for each attribute. So let me delete this part as well. So first thing that I will declare is the AMI. So the AMI will remain same for all these three EC2 instances. I'll take the same ID, AMI ID here. Okay. I'll give the indentation, two spaces. Then I will declare the for each attribute. For underscore each, it is a set of it is a set of maps. So it will be written like this format only. So we have already discussed how to write a set of maps. So it will have key and value, right? So the key. So let me call it as a web server is equal to t2 dot small. Then we have, let's say, app server, which is equal to t2 dot micro. DB server, database server, which is equal to t2 dot medium. So I've declared the key and value like this. Now, since this is a map of values, so you have to separate them with a comma. It will be separated with a comma like this. So you have written this. Now what I want is, I want to give the tags. So tags is equal to name is equal to each dot key. So it will take the key name. Now if you want, you can write it in a single line like this as well. Okay. So just for understanding, you can write it like this as well. But just for aesthetics, it will be written in this format. Right? So you can write it like this. I'm writing this just for your understanding. So what I'm taken is tags. I will pick up each dot key and instance type. Instance underscore type is equal to each dot value. So what this will do is it will create a web server with T2 small, it will create an app server with T2 micro, and it will create a DB server with T2 dot media. So what I'm picking is I'm picking each key and each value like this. That's it. So this is how you can make use of the for each attribute. Very simple to understand. So each key will have the key, whatever key that you have, and each value will have the value like this. So let's try to apply this and let's see what will happen. So logically, I need it should create three EC2 instances and with three different instance types. Right? That is how it should work. Now you can see three resources have been added. So go back. Let's go back to our AWS account and let's verify whether three instances have been created or not. Let me go refresh this. I'll go to instances, refresh. Now you can see here three instances got created: web server, DB server, app server, and with three different instance types. Right? So in case if you have such requirements wherein you want to create three different instances with the different names and different instance types, then this can be achieved with the help of for each attribute. Okay, so this is how you can do it. Now don't forget to delete the infrastructure after you have done the practical so that you don't incur unnecessary charges. So just run this Terraform destroy and it will delete whatever has been created. Okay. Now there are two more sections here in the notes. I want you to do this practical. So this is how you can create an VPC using the for each attribute. Okay, I want you to practice this and let's check the output. Once you are done, delete it. Okay, so this will be written in the main.tf file. Okay, so whatever code you have written, just remove the main.tf file, just add this code and do the practical. Do it on your own. How to create VPC, how to create S3 bucket. So all this I have added here. So this is how you can create an S3 bucket using input and variable and output block. Right. So you have to create the variables.tf file, main.tf file, and this is how you can create an S3 bucket as well. So I want you to do the practical, and if you face any difficulty, let me know. So this I have added in the notes just for your practice. One more thing, this also I missed to explain this. So this is how you can make use of. Let's say I want to declare multiple variable, multiple instance name. So this can be done with the help of this var.server name count.index. So this you can practice it, or if you want, I can explain it in 2 minutes. So let me go back. So this is still in the destroying state. So count.index we had used. If you remember, we made use of the count.index, using which we can create server 123. But I want to give a different names. I don't want to make use of server 123. I want to call them as let's say Ansible server, Jenkins server, Docker server, or any names I want to give. So how can that be achieved? So using count.index only, this can be achieved. You have to just create a variable with a name, with the different names of instances. Like for example, you have to declare the variable and give the name as, or you can just give the name as names like this. And here you can declare the variables. So default is equal to, now this is a list of different servers. So you have to start with the square brackets and you have to just add the list. So let's say Ansible server, comma, Docker, comma, Git server, like this. Any names you want to give, you can give it like this. So I'm giving there just different names, variety of names. So you have to add it like a list. And what is the type? So type is equal to list. So this is how you have to define the variables like this. Like this you can create it. Okay. And then you have to use this in the tags. So you have to create a resource block, resource AWS underscore instance, my EC2, open it, and AMI is equal to AMI ID, let's say 12345, whatever. Then instance underscore type is equal to, let's say t2.micro. And then in the tags, how to call this multiple servers, you have to just give tags is equal to, open it. So name is equal to, so this is a list of different variables. So this will be like var dot names count dot index. Okay, so this is how it should be written. Let me just verify it. Var dot name. So here I've given server name. We instead have written var dot name count dot index like this. So this is how you can write it, and you can just close the bracket here for tags and the bracket for resource. So this is how you can write it. If you want, I'll just show it here. Let me check whether it has been destroyed or not. Yes, this has been destroyed. So let me delete this part and add this. Okay, P2 micro. And here I can declare the variables. So if you want, you can create a separate file variables.pf, or I will declare it here variables block, and just pick up this part, paste it here, and this should be it. That is fine. So this is how you can make use of count.index, and since the number of EC2 instances are 3, we need to define count equal to 3. Here also t2.micro should be in quotes. Now let's try to create it. Terraform apply. And they should create 3 EC2 instances with Ansible server, Docker server, and Git server names like this. Okay, so this is how you can also give different names. Instead of using server 123, you can just create a variable. In that you have to define the default. You have to define the default variables. Okay, you have to add default names, and then you can call it in the tags var.names count.index. That's it. So this is considered as the zeroth position. This is at the first position, and this is at the second position. So it will always start with 0, 1, 2, 3. If you add here count.index plus 1, then this Docker server and Git server will only be created. So this will skip that 0 position. Okay, so index will always start with 0, 1, 2 like that. So the 0 position is Ansible server, Docker server, and Git server. So this part I missed in count and count.index. So you can just go through the notes, okay, and whatever is missed, you can just practice them. Only I think the last part I've kept it for your practice, how to create a VPC and how to create an S3 bucket. Go through it. If you face any difficulty, then let me know. So this will take some time. We'll wait for 2 more minutes. But it's still in the creating state. Now you can see here, 3 instances got created with 3 different names. So this is how you can make use of count and count.index. Okay, so this is what I wanted to show. That's it. So I'm done from my side. If you have any questions, then please go ahead, or else we can wrap up for today. So tomorrow we'll cover the remaining modules, remaining blocks, module block, provisioner block, and the backend block. Any questions, anyone? All right then. So we will wrap up for today. Don't forget to delete or destroy the resources after you are done the practical. Okay, or else you will start getting unnecessary charges. Okay. Thank you everyone, and we will connect again tomorrow. Thank you. Thank you.
Thank you.
Thank you.